Hello, let's look at this problem. If alpha, beta, and gamma are the roots of x cubed minus 4x squared minus 5x minus 1 is equal to 0. Without solving the equation, we have to find the equation whose roots are alpha squared, beta squared, and gamma squared. We have to know the relationship between the roots of any cubic equation and the coefficients. A cubic equation is of the form ax squared, ax cubed plus bx squared plus cx plus d is equal to 0. If the roots are alpha, beta, and gamma, then the sum of the roots alpha plus beta plus gamma is of the relation can be obtained by using minus b over a. So this is the sum of roots. Then we have what we call sum of product pairs. And the product pairs are alpha beta, alpha gamma, and then beta alpha. The sum of the product pairs can be obtained by using the relation C over D, sum of product pairs. Then, the product of the roots alpha, beta, gamma can be obtained by using the relation minus D over A. So this is product of roots. So let's look at the original equation. The sum of roots, which is alpha plus beta plus gamma, is minus b over a, which is minus negative 4 over 1, and that will give us 4. Then the sum of the product pairs alpha beta plus alpha gamma plus beta gamma is c over a, which is minus 5 over 1, which is negative 5. Then the product of root alpha beta gamma is minus d over a, and this is minus negative 1 over 1, and that will give us 1. So let's leave these values there. We'll come back for them and highlight them. Now let's go to our new equation. The roots are alpha squared, beta squared, gamma squared. The sum of this root will become alpha squared plus beta squared plus gamma squared. We need to manipulate this expression so that we get expressions involving these ones so that we can slot their values inside to get our sum. So first, let's pick these two. This is an identity for sum of two cubes. You can write that. This 2 alone becomes alpha plus beta all squared minus 2 alpha beta, then plus our gamma squared. Let's bring our gamma squared close to this one. Alpha plus beta all squared plus gamma squared minus 2 alpha beta. These two still constitute sum of two cubes. You can write that. This is alpha plus beta plus gamma all squared minus 2 alpha gamma squared alpha plus beta. So this one alone exists. then minus 2 alpha beta. We know the value for this. This is the sum of the original root, which is 4. So this will be 4 squared. Then we open the bracket here. Sorry, this should not be squared. It is 2 gamma times alpha plus beta. So when you open the bracket, we get 2 alpha gamma minus 2 beta gamma, then minus 2 alpha beta. This becomes 16 minus, we factorize 2 out and we have alpha gamma plus beta gamma plus alpha beta. This expression 2 is the sum of the product pairs. Sum of the product pairs, which is negative 5. Let's throw that one into it. We will have 16 minus 2 multiplying negative 5. And this will translate into 16 plus 10. And that will give us 26. So we have gotten the sum of the new root as 26. Let's take note of this. And go to the product, the sum of the product pairs. Sum of product pairs. Product pairs of new roots. Sum of product pairs of new roots. We are going to have alpha squared beta squared plus alpha squared gamma squared plus beta squared gamma squared. This can be written as alpha beta all squared plus alpha gamma all squared plus beta gamma all squared. This you can use the sum of 2 cubes. That will be alpha beta plus alpha gamma all squared minus 2 multiplying alpha beta multiplying alpha gamma, then plus beta alpha all squared. This and that also the sum of 2 cubes. So let's write that one too. This is alpha beta plus alpha gamma plus beta alpha all squared minus 2 beta gamma multiplying alpha beta plus alpha gamma, then minus this one, minus 2. Let me just multiply them. This will give me 2 alpha squared beta gamma. We know the value for this expression, so let's throw that one into it. That's the partial sum, the product of the sum of the product pairs, and it's negative 5. So let's do that one inside. No, it's actually, yeah, product pair. So negative 5 squared. Then we open the bracket here. When I open the bracket here, I'll get 2 alpha beta squared gamma, then minus 2 alpha beta gamma squared, then minus 2 alpha squared beta. No, there shouldn't be any square here. Let me see. Yeah, there shouldn't be any square here. This it was obtained from the multiplication of this. So it is just 2 alpha squared beta gamma. Beta gamma. Then this is 25. We'll factorize 2 alpha beta gamma out from the whole of this expression. This side will be left with only beta. This side will be left with only gamma. And this side will be left with only alpha. We know the value for alpha beta gamma. And we know the value for beta plus gamma plus alpha. That's the sum. Let's throw those ones inside. So the product is 1 and the sum is 4. So we're going to get 25, that's the square of the negative 5, which is 25 minus 2 multiplying 1 multiplying 4. So 25 minus 8, and we'll get 17. So this becomes the product, the sum of the product pairs. Let's go to product of new roots. Product of new roots. That will be alpha squared, beta squared, gamma squared, which can be written as alpha, beta, gamma all squared. And alpha, beta, gamma all squared, we know the value as 1, so 1 squared will be 1. So that's that. A cubic function can obtain the roots of the equation by using the relation x cubed minus sum of roots x squared plus products sum of product pairs x, then minus product of roots. So we have x cubed minus sum of roots. Let's go and see the sum of our new roots. The sum of our new root was 26. So minus 26 x squared. Then the product of the sum of the product pairs. We had 17. That is, we started from here. Sum of product pairs is 17. So plus 17x, then minus product of root, which we had as 1, is equal to 0. So this becomes our new equation. Thank you very much for watching, and don't forget to subscribe to my channel. Goodbye.